So the first question, how could words have begun? Now we've got an answer after some years of working on a blog. And the answer is that 3.3 million years ago, this is pre-Homo, we're still in the Australopithecus stage, our human lineage had become basically hairless. We got a little hair in a few places. I'm not going to go into all the evidence for that now, but of course I do that in the book. But going hairless presents a crisis. Really, I mean, we talk a lot about becoming bipeds and all the changes that makes and stresses on your back. Going hairless also is a tremendous difficulty for apes. Think about it. Ape mothers carry their kids with the kids hanging on the hair. The mother doesn't have to pay much attention to it. If you've got no hair, the baby can't hang on. So when you have something to do, you have to put your baby on the ground. And when you're going to start traveling, you have to pick the baby up and carry it. Babies are a burden for every mother mouse, mother dog, mother chimpanzee. They are extra burdens for humans. They're longer, they're more dependent, and they can't help themselves at all. You have to carry them. So that a solution to that had to be worked out. And another threat from hair is grooming. Grooming is essential to ape society. Grooming is one ape is picking insects out of the hair of the other. It's a very intimate thing. It creates bonds between apes so that they can work without getting into fights all the time. They can be comfortable with this ape sitting right next to them, reaching for figs while they're reaching for figs. Instead of constantly going, get the heck out of my way, I'm reaching for that fig, they can have a semi-peaceful time. Well, that's gone. What happens when you can't talk? When you can't pick the bugs from something? That a social structure was destroyed. So a classic biological solution to the need for some kind of interaction is vocal. You've got birds, they sing songs, some of them. You've got humpback whales, they sing songs. We don't know what those songs are about exactly, but we do know that they learned the song. And there seems to be some kind of connection being made. Also elephants, they do the same thing. They talk, pardon me. They communicate with very low sounds. This is only recently discovered, so that a bull elephant a couple miles away can pass messages to the herd, and the herd can pass messages to the bull. So that went on for perhaps 1.5 million years, when we were in the stage that we still see a little bit of today in children. Babies coo, goo, their mothers coo, goo back. In this picture, I'm pretty sure that neither one of them is saying pass the salt or anything in English, they're just making noises. Well, we think of that as a useful thing today, but for maybe as long as 1.5 million years, the human lineage went through a bird-like phase in which they vocalized a great deal, had all kinds of emotional contact, and they didn't say a word. But this sort of a situation in which you're making vocalizations and you're going through all kinds of emotional connections it gives an opportunity for you to create an association between this sound, whatever random sound you made, and this person or this thing, so that all of a sudden you have the name, something to point at. Ooh, lion, mama. So that brings us to the next question. Well, why do humans only speak? That was the second mystery I had. And the answer is in the speech triangle. Humans speak because we have cooperation. We need cooperation in order to speak. We also need intelligence to speak. Now, apes, by the way, are very intelligent. And their difficulty is that they don't cooperate. If you look at the fossils of the Homo lineage going back 2 3/4 million years to Homo habilis right down to Homo sapiens, what you see is the brain is getting bigger. That's very, very clear in the fossil record. The brain keeps getting bigger, so that now our brain is 3 times the size of a chimp's. Homo erectus by Homo erectus was 2 times the size of a chimp, and even Homo habilis is a little bit bigger. Now, we've always looked on this as a sign that we were getting smarter. And it is a sign we're getting smarter. But it's also a sign we're getting more and more cooperative. It's too complicated to go into in this lecture. Of course, I discuss it fully in the book. But basically, there is a limit that any species can have in its brain, its size. And apes have reached that limit. They're as smart as they can be. It takes them, they spend a long time between giving birth, which is a very energy demanding task. Their digestive systems have been simplified quite a bit. So what could they do? Well, it turns out that when you can break this brain ceiling if you become cooperative. Many species become cooperative, particularly birds do a lot of nesting and rearing children together and so forth. Their brains get bigger. So the reason, if you have to have a cooperation plus intelligence to get language. And there are not that many cooperative species, and there are not that many intelligent species. And you have to get both of them, a combination. So it's possible that there could be another talking species, but it would have to have this very rare combination of intelligence and cooperation. Apes don't talk because they don't cooperate. Dolphins cooperate, but they're not, I mean, they're smart. I don't want to badmouth a dolphin. But they're not as smart as an ape. They're not as smart as us. So they're limited also. So 1.8 million years ago, my goodness, what's going on with this? We had vocalization, we had cooperation, we had intelligence, so we had enough to produce the first level of topics, which is a subject. Enough to say, there's a lion. Lion. In fact, apes are smart enough to do that today, and they do it with sign language when they've been taught it and they're in human settings. But they don't do it naturally because they're not cooperative and they're not vocalizing. Well, and they don't do it. Even the captive apes don't talk amongst themselves. They're not sitting there while they're waiting for something to happen, passing comments back and forth. So that brings us to the next question: what makes language special? And that's perhaps the hardest one. Most people talk about it as communication. I was at an event just this weekend where people were saying to me, well, many animals communicate. Yes, many animals communicate. Communication is not the secret of language. Computers communicate. And what does that mean? Computers control one another. Communication in the computational world means control. Mathematicians communicate. What does that mean? They engage in symbolic reasoning. Very high, maybe it's fancier than language. It's different. Animals communicate as well. They can beg, they can seek a mate, they can claim territory, they can control attempts, and they can do many other things. All of these things we can do with language. But we can do something extra with language which is what makes language different. I'm going to read a small passage from my book where I say, we've got, with language, a true biological novelty, a cooperative species able to share perception of a topic by directing attention with words. It is almost as though our lineage developed a new sense, a cooperative sense, and for the first time, that individuals know what another sees, hears, or even feels. I can tell you what I'm thinking, and you can tell me what you're thinking about what I'm thinking. No other species in the world can do that. It's kind of mind reading. I can go to this window, you can ask me what's out there, I can tell you, and you know what's out there. Dogs can't do that. It's quite a marvel. This is, language and perception have very similar structures. Both are about something. With language, we can work it like a spotlight. We can pick out the object in the environment, say, there's a tightrope walker. All the other things are kept in the darkness. It's about something. Language perception has a point of view. If I'm looking up at the tightrope walker, I see one thing. If I'm looking down, I see another thing. I can say, I bought a shirt today. What could somebody else say? I sold a shirt today. It's the same thing seen from two different perspectives. Mathematics doesn't do that. Computer languages don't do that. Animal cries don't do that. But you really can't escape having a point of view with language and perception.
Let me take a slug of water here. Language and perception also share perspective. That means that you can zoom in with language or you can zoom out. Now, on perspective, you can look closely, you can focus your attention on something small like the shoes of the tightrope walker, or you could focus your attention on the whole tightrope and the scene beyond. And in language, you can say, the tightrope walker wore special shoes, or you can say, 30,000 people watched the tightrope walker without noticing the special shoes. Once I understood all of this and knew both sides of the debates, I was ready to write my book.